So we're going to do a sticky tape prep or an adhesive tape prep that is really useful for detecting bacterial and yeast infections in particular, and we also use it for some screening for ringworm and a range of other infections in dog skin. And it's a really simple technique, and all you need is some basic equipment, some sticky tape that has quite a wide diameter to it so that it spreads over most of the slide, and it needs just to be plain, good quality tape that has good adhesiveness, so when you're pushing it onto the skin you get some good stickiness there and get good samples. And then you just need some glass slides, which as standard glass slides used for all our cytology. So the process is simply collecting, and I'll just show you first and then we'll collect from Lexi. So we collect a piece of tape that's about that size that ultimately then fits nicely onto the glass slide and gives you a good range of skin to examine. Okay, so we need our Lexi to lie down. Hey, sweetheart. Good girl. See, drop down. Roll you over. And one of the beauties of the sticky tape is that you can sample all sorts of areas very easily, such as between the toes, where Lexi's had lots of yeast infections in the past. So we're just pushing the tape. Don't have to, in fact it's bad to clip the hair because you get hairs stuck onto the sticky tape, little fragments. What we want are the skin cells. So I'm just pushing it onto her skin. Good girl, Miss Lexi, until we get a good sample adhering to the tape. And I'll often do all 4 feet on the same tape and then different sites with different tapes. We then fix one end of the tape onto the glass slide, and I curl it up into a little offset cylinder so that it's ready for staining when we take it into the lab to do the staining. I'll usually mark where they've come from as well, so we can write on there with a pencil, which I'll get in a moment, and the location of the samples. The other one I want to get from Lexi today is from her ventral abdomen, where she's had some pyoderma lesions. Good girl, Miss Lexi, you're such a good girl. And she's just had some biopsies, which was from a little bit of an unusual bacterial infection it turned out to be. So I'm just sampling the skin in that area to see what's happening on there today. Good girl, Lex. And you can see on the sample, doesn't look like we've done much, but you get a nice adherence of skin cells onto there, which makes a good sample for staining. And that's pretty much it. You can collect from a whole range of lesions. You can collect from scaly areas, papular areas, crusting sites, pretty much any lesions you can collect from, and we'll go through the staining process in a moment. So don't forget to write your locations on your samples. So we've got abdomen on this one and we've got feet on this one, so that it's very easy to know which samples are which. Sometimes you might have yeast on the feet and not on other areas, so to know which body part you're looking at is really, really helpful. Just some tips to help make the process as simple as possible and to help avoid some of the traps that can happen with this test. It is a very simple test, but the critical things to me, certainly the type of sticky tape, that it is this width that gets across most of the glass slide, that it isn't patterned or invisible tape, which you don't see through as well when you're looking under the microscope, and that it is quite adhesive. So older tapes, or it doesn't have to be any particular brand. When you look at the literature, they talk about Scotch tape. In fact, I don't find that as good as some of them. This is just Officeworks tape, but it really doesn't matter as long as it's clear and nicely adhesive. So that's step one. Collecting them, I guess, is step two. The tips, there's a whole range of skin that you'll be collecting from. Sometimes it's very greasy skin and there's seemingly less adherence, but usually you still get some good keratinocytes on there. If it's moist skin at all, you still get nice samples too. If you find there's a lot of debris, if it's a country dog, outdoor dog that's been in the fields a lot, then you'll get a whole lot of material from the environment on there, and horses are like that too. We'll often take one on the area of interest. If there's lots of dust and debris, then chuck that one away and then go back and get your skin sample. But that's pretty much it. It's a fairly straightforward test, pushing the piece of sticky tape firmly onto your lesional skin until you've got nice adherence onto the tape. Okay, so for staining the slides, we use generally the straightforward Diff Quick stain, but without the fixer for the sticky tape. The fixer dissolves some of the adhesive on the tape and makes the whole picture a little bit cloudier, so it doesn't damage it completely, but it's definitely preferable not to do the fixing. So it's 6 dips that I'll do into the red stain, about 1 second dips, depends how much time poor you are and how fast you need to be. It just needs to be stained. You can collect these and save them unstained until you have time to look at them. So if you don't have time in the consult, then it's far better not to stain them until you're ready to actually look at them. They do seem to lose their sharpness fairly quickly. So once you've been in the blue stain, you run a gentle stream of water over the slide until the stain is rinsed off, and then pop it onto a swab or a tissue and uncurl your little cylinder. And that's an easy way then to get the sample adhering to the surface. I then usually grab a tissue and smear over the top of the slide so that you've got a nice flat surface. You can see it adheres very nicely to the tape, and it makes it very easy to examine when you're under the microscope. An alternate way that's been used for a long time is to drop a few drops of blue dye onto the slide and then just smear that over the tape, but it doesn't distribute as nicely, and it doesn't give you that nice even surface that dipping does. So just to repeat that, 6 dips into your red stain. And occasionally, if you haven't got really sticky tape, it'll fall off into the stain and leave your slide. It's certainly not a disaster. Grab some forceps and you can pick them up and continue to stain. That's more so if you've got really greasy skin and you've managed to not be able to adhere it firmly to the slide, but mostly you're not going to need to do that. Dip it off a bit, water on, and then just... You don't have to worry about the cells being washed off. That's the beauty of the adhesive part of the tape, is you've really got good adherence there. Uncurl that one, lie it flat and smear it over. When you go to the microscope, we'll have a look at that soon. You can put your oil straight on top, but you do need the slides to be dry. If they're wet, they're going to not move across the stage as you're scanning around, and you need to have a dry surface to put the oil on top. So as far as not staining the tapes and leaving them for a while, if you're busy, I even have people mail them in, so a few days out of between processing and collecting them seems to be okay. There's no clear guidelines as to how long they last, and I think to read them within 24 hours or so is ideal, but they certainly can last quite a bit longer than that. If I'm storing them, I would keep them generally in a slide container, so I'd pop them loosely. I'd rather than keeping them curled, I'd tend to just lie them loosely on a glass slide, pop them in a slide holder, and keep them somewhere room temperature. So with the microscope, this is probably the trickiest part of looking at the sticky tape preps, is to get a good representation of what's going on. So you do a fair bit of scanning on low power on the lowest lens, so the 4x lens usually on most microscopes, which is often the shortest lens. And if you scan around the slide, we can see on the screen here what I'm actually able to see down the microscope. And if you scan over the slide, you'll see there's a lot of keratinocytes scattered here. They can be mainly single ones. There are rolled up ones that are staining more, which are meant to come from the hair follicles more, and then there are single ones. When we've got pyoderma or active crusting. You've got clusters of keratinocytes with rims of neutrophils, purple granular material around the edges of them. So we're usually scanning around looking for areas like that, or looking for areas that are very dense. And for example, something like that that's in the middle of the screen now would be an area, if there's not much else to see on the slide, which is the case. This is from Lexi's feet, so she hasn't got lesions at the moment, but she's had a history of having yeast infections, so we want to look. You pop your oil into the middle of the field of view, and then I usually just swing straight onto the oil lens at that point. We need oil to know whether we've got bacteria or not, so it is important to be looking under oil immersion. And we're scanning around. There's our keratinocytes, our follicular keratinocytes up close, and we're scanning around looking to see whether we've got evidence of any yeast or bacteria there. That's probably a yeast in the middle. It's not a perfect one. One of the tips with looking at tape preps is learning what to ignore, and that you can't identify everything that you see. So if I see something that looks suspicious, I'll keep looking until I find something that's convincing. And if I don't, well, I'm happy to say that's a fairly normal skin sample. And I can't see in that little area much more going on. I'll often swing back to low power, find another site to go up closer to, and have another look. So another little area there that's got a cluster of keratinocytes. Swing onto the oil lens and looking to see, that's a little mould spore. Looks quite big on the screen, the big greeny blue shape with a clear outline. So we can see a range of contaminants that are incidental findings. What we're really looking for, there's another one, a nice big fat green bean-shaped one, but what we're looking for are yeast or neutrophils and bacteria, which at least in this sample of Lexi's feet don't seem to be there, which is good. So this is the sample from Lexi's ventral abdomen where she'd had the biopsies recently, and I was worried about pyoderma in that she's had a history there. And this is the sort of cluster that we see of keratinocytes, the blue keratinocytes together, and then the purple ring of granular material around the outside. So that's an area usually of neutrophils surrounding keratinocytes, and that's an area of interest to look at under closer magnification. So we're still on the lowest power, the 4x lens at that point. Again, pop a little bit of oil into the middle of your field and swing around the oil lens. So that's 100x lens, 1,000x magnification. To see well, it is important that you have full light on the oil lens. So you need to have your condenser, which is the area, usually has a little wheel on the side of the microscope. You can see as that goes down, it gets darker. It does under my field, doesn't quite as much on the screen. It needs to be all the way up, and then the diaphragm, which controls the light, that certainly makes it darker, has to be all the way open to get maximum light so you can see well under the oil lens. This is our cluster of neutrophils. And you have to get used to the appearance of neutrophils on the adhesive tape. They're not like in the bloodstream where you've got lovely pristine cells and a clear cytoplasm and cell outline. We've got multi-nucleated, multiple bodies in the nucleus, and that's the main thing that you see. You also see this purple wispy stranding, which is the nuclear material starting to degenerate and break down. You've got some clear neutrophils, and then you've got a whole cluster of degenerating material. And what we're looking for inside these clusters are whether there are bacteria, usually bacterial cocci, associated with the neutrophils. And that's what we need to see to say that we're dealing with pyoderma. And in this instance, I can't see any clear bacteria. They stand out as deeper blue staining and very clearly paired. So they contrast against the purple of the neutrophils and the blue of the keratinocytes. We'll have another scan, so we'll head back to low power again. There's another cluster here. How I move around the slide is somewhat random. I do like to go over a fair width of the slide and breadth of the slide to see a reasonable range of what's on there. So it's somewhat like on a sticky tape, on a skin scraping where you'll scan systematically up and down, but you certainly don't have to cover the whole slide. So once you've found some areas of interest, like here where we've got clusters of neutrophils, I'll pause and have a look. It's often hard to go back and find those spots, especially if they're smaller areas, so I'm tending to look at them as I'm going. Into focus under oil, and again, lots of neutrophils there. Stranded nuclear material, the blue base of keratinocytes in the background, but no bacteria to see on this sample. There's lots of little melanin granules in this one, which are the little brown speckles. They look a little bit like bacteria, and they're easy sometimes to be tricked that they're bacteria. And once you can see them, they're actually scattered right through here. In dark stained skin, you'll see a lot more keratinocytes, and a lot more melanin granules on the keratinocytes. And the only importance of knowing they're there is to know they're not bacteria. Otherwise, they really don't have any importance. They're most easily distinguished because of their colour, and there's always a bit of a brown tinge to them. They're also not quite paired and round like cockeye. They're slightly ellipsoid, and they're not parallel-sided like rods, so their shape is different to rods and cockeye, but they're also very tiny. So if you find you're seeing things like speckles that have brown to them, then they're probably going to be lots of melanin granules. A good rule of thumb when you're looking at sticky tapes is if you can't clearly identify anything as bacteria or yeast, then they're probably not there. And if you're umming and ahhing and thinking maybe, then the best answer is to say there's nothing there. They need to be convincing to be there. And being confident with saying there's no infection there is just as important as being able to accurately identify when there is infection. So low power view, keratinocytes, so sometimes more of them clustering together and pale blue, and sometimes these dark staining, which we think are coming from the follicles, but they're keratinocytes curled that have come out of the follicles. Cluster of, at that power you can't tell for sure, but suspect neutrophils, so something that's of interest to go down to oil and have a look at. And so scanning around on low power, that's the sort of things we'll be looking for. There's some hairs. When we're looking at dermatophytes, we'll examine the hairs, and the sticky tape's very good at adhering hairs to it. So looking at the morphology of the hairs, whether they're nice uniform outline and any hints of fungal elements in them. So we've got a little area of interest there. Pop some oil on again in the middle. Swing your oil lens around, turn your light right up to maximum and into focus. And there we've got, you might say, what is that smudge? But that is going to be a neutrophil, multi-lobed nucleus, and this will probably be lots of degenerate neutrophil nuclear material. And you scan around and can see more that's convincing. Neutrophils and this strandy material. The background of keratinocytes, some little melanin granules scattered through there. The little browny tinge to them definitely gives them away. But no pathogens that I can see so far in this sample. Another little cluster, again the brown colour and the granular speckled, I sort of think of it as salt and pepper sprinkled on the keratinocytes is a bit what the melanin granules look like. There's a whole lot more there, again speckled through. So only importance is to know they're not bacteria.